area and perimeter, my friends. Area and perimeter. This is the basics of geometry. So was yesterday, but now we're really diving into shapes. There's something you need to know in terms of shapes. There's this little thing called two-dimensional shapes and this little thing called three-dimensional shapes. In the two-dimensional world, there's a couple shapes that we have we've come to know and love. I'll list out a couple, such as the famous square and the rectangle. Can anybody name a couple more shapes? Have me draw it. Triangle, yes, that's one. Circle. Nobody said anything, by the way. Circle, that's another one. What else? Octagon. So the octagon, hexagon, pentagon, all that's good. All that is fine and dandy. There is, in this class though, we're not going to really touch those, which is fine. But within that same family, we do have a couple other ones, such as the trapezoid. And then the trapezoid again. Those are both trapezoids, by the way. And then the last one that we're going to deal with in this class only. A parallelogram. All it is a rectangle just skewed off a bit, right? That's the 2D world, and we are going to get familiar with everything we need to know in regards to the 2D world today. So the 3D world, that's what we'll hit next week, so don't worry about that just yet. But continuing on with the 2D world. In the 2D world, when dealing with these two-dimensional shapes, there's some stuff you need to know. When given any of these shapes, you're going to be asked to find one of the two things that are incorporated in the 2D world, which is area and perimeter. Area and perimeter. In 3D world, we are going to deal with something called volume and surface area. Surface area, but that's for that side of things. In the 2D world, we just deal with area and perimeter, and that's what we're dealing with today. Now, can anybody tell me what area is?
The space inside of the shape.
The inside of the shape, the measurement inside the shape. So think of that as the inside. Perimeter, the complete opposite, it is the outside of the shape. The measurement outside the shape. So we're going to take a look at a couple stuff right now. If we look at this famous shape that we all know and love, which is a square. Let's say we're given 2 there. Well, yeah. Actually, they don't even have to give you a measurement there. All they need to give you 1, but because it's a square, it's the same side all along. All around. Okay, so what I just handed y'all is a formula sheet. Now, those of you taking your GED, that formula sheet is very handy because that is an exact replica of what you'll be able to use on the GED test. That right there. Now, this class, the reason why we're using that is because A, we got a couple GED students in here, but because B, it's all the same thing. It's just whatever formula sheet you use, they're all the same formulas. And we are getting into the realm of geometry, which incorporates shapes, which incorporates a lot of formulas. Now, yesterday we went over one particular formula, which was the Pythagorean theorem. A squared plus B squared equals C squared. And it was just putting in the numbers in the formula and then solving, right? my friends, geometry is literally the same thing. It's just looking at the formula sheet for the correct formula and punching in the correct data into the correct formula and then pushing enter on your calculator and then being done with it. So there's a couple steps that you need to keep in mind when it comes down to finding the area and perimeter of 2D shapes. The first thing is knowing what shape is in front of you. For instance, this one, it's a square, right? It's a square, and so the square has its own formula to find its area and its perimeter. Now, the square and rectangle is actually pretty straightforward to find even without a formula. But just for, math purposes, we're just going to follow the formula. We're just going to get familiar with using the formula and inputting it in and then finding the area or perimeter. So, get your formula sheet, my friends. Let's pretend this right here is a word problem. This is a word problem, and the word problem is Neil's yard is in the shape of the figure below, and they give us the figure below. They give us one dimension for my yard, which happens to be 2 feet. Small yard. They just give us one dimension, and they say, how much fencing does Neil need to put around his yard? So if you notice right then and there, the question did not ask for the area or perimeter. They didn't say it point blank. They didn't say it up front. But it's your job to know that because perimeter means around the shape, it's your job to know that they are asking for the perimeter of my yard. So that being said, you now know what the question is asking for. It's asking for the perimeter. You should know what shape is in front of you, which is a square. So what do? Well, that's when we go to our formula sheet. We look at the perimeter of A, colon. That's the section that we're going to need to see. I think we could look at it here, because I might have it up here. If you look here, you are going to be looking for the perimeter of A, and then there's all the shapes, right? Well, a couple of the shapes. And there's a couple of the formula. The thing is, you could use the formulas, I guess, of a square. It just means 4S. S stands for side, so you just do 4 times S. Well, what's one of my sides on my figure? 2. So you just do 4 times 2, right? And that'll give you the perimeter. But here's the thing. There's not much formulas for the perimeter of much shapes. And the reason is because, my friends, the perimeter of all these 2D shapes, sure, there's a couple formulas to it, but you don't really need to use a formula. When it comes down to the perimeter, all you ever have to do is add all of its outside dimensions. So, this one just has a 2, but because it's a square, you should know that it's 2 all around. Well, tell me, what's 2 plus 2 plus 2 plus 2? 2 plus 2 is 4, plus 2 equals 6, plus 2 equals 8. So the perimeter equals 8. It doesn't matter what shape it is, whether it's a triangle. If they give us a 8 there and a 9 there, sure, you might not be given this missing dimension, but it's your job to know that that one is also 8. What's the perimeter of this triangle? Sure, you could use the little perimeter of a triangle formula, but again, perimeter. All you ever have to do to find the perimeter of 2D shapes is add up all the sides, which means all you have to do is 8 plus 8 plus 9. That's straightforward. any 2D shape that's given, except for this circle, but I'll get there. Let's say we're given the famous trapezoid. We're given 3 there, 6, 4, 4. Somebody tell me the shape of this trapezoid, the perimeter of this trapezoid. Well, 4 plus 4 is 8, plus 3 is 11, plus 6 is 17. So the perimeter is 17. So make that a mental note. In order to find the perimeter of any 2D shape, all you ever have to do is add up all of its outside dimensions. Pretty straightforward. There's a reason why I started with perimeters, because that's the easy one. You just add up all the outsides. Now comes the fun one, which is finding the area of certain shapes. Let's say we're given this trapezoid here. We're given 4, we're given 6, we're given 5. And we're then labeled with something like this. So tell me, my friends, tell me. If the question is, Neil's yard is in the shape, has a shape like the figure below. He wants to know how much grass to plant in his yard. Given the following units or dimensions and all that, how much grass fertilizer does Neil need to buy in order to fill his whole entire yard with grass? Well, tell me, first of all, always ask these steps in your head. What are they asking for there? They ask for the grass, the amount of grass to plant inside. Inside means what? Area. So you know they're asking for the area. Tell me, what shape does my yard have? Trapezoid, right? So that's the other thing. You got to memorize your shapes. So now, what must be your third step? Go to the area of A. So we're now looking at this section up here, area of A. And, well, you've already determined what it was. It was the trapezoid shape. But we're looking for the area of a trapezoid formula. And what you're going to do is input the dimensions that they gave us into the formula. So, tell me, I'm going to take this off so I can make space, but tell me, looking at your formula sheets, and tell me, what is the formula of a trapezoid? The area of a trapezoid formula. Area equals 1/2 times what? Height times base 1 plus base 2. So this is a weird looking formula, I know. But it's going to be clear as day in a second. So, area equals, well, 1/2 is an actual number, so all you got to do is put 1/2. My height, can somebody tell me what is the height of this trapezoid? 4. And they labeled it right here. Don't get it ever confused with the 5. Students always ask me, well, then why did they put the 5 there? It's either A, because the following question is they're going to ask you for the perimeter, right? And you need that slant height to find the perimeter, because that's the actual side of the trapezoid. Or they just put that there to trick you, to see whether you'll put the 5 in for the height. But don't fall for their trick. You know height means vertical, which means the 4 is the height. Now comes this little famous base 1 plus base 2. What's my base 1? Sure, 6. It doesn't really matter. And base 2 could be 4. It doesn't matter because all you're doing is adding. It doesn't matter if you switch them. But it's important to know that the trapezoid is the shape that has 2 bases in it. So you got to put them in base 1 and base 2. Now that you have that, my friends, now that you filled in the formula with the designated data, guess what you have to do? Just punch all of that exactly the way it is in your fancy little calculators. Push enter, and out pops out the answer. Can somebody please tell me what the area is of this trapezoid? So once you've done that in your calculator, you got area equals 20. And just like that, you found the amount of fertilizer bags. The units never matter. They'll tell you the units. If they say this one was inches or feet or yards, it doesn't ever matter. Because how many fertilizers do you need? Well, 20 cubic inches. They'll probably give you something weird. Don't worry about the units. All we care about is getting the correct number. The area equals 20. So that's as straightforward as area and perimeter is. Perimeter, all we have to do is add up all of the outside sides. Area, how do you find the area of shapes? Well, you look at the formula. Do you have to memorize these formulas? For my class, no. You'll be allowed to use this on your final, on your quiz, on everything. For those of you taking your GED, do you have to memorize this? No, because this exact paper will be on the computer for you. For those of you taking any upper level classes or any other different types of tests, do you have to memorize formulas? 50-50. They'll either provide you a formula sheet or you just have to go in memorizing formulas. But no matter what, to find the area of shapes, you have to go in knowing your formulas. There are a couple shapes, such as, well, if we look at it, the square again, or even the rectangle. Let's say they give us 3 there and 2 there. Sure, they do have an area of a rectangle formula, but to find the area of a rectangle and square, those are the ones that we have come to kind of learn on a daily basis. All you ever have to do to find the area of a rectangle or a square is to multiply 2 sides. So in this case, they gave us a 3 and 2. All you have to do is multiply them. What's 3 times 2?
6.
6. And that's the area of this rectangle. But other than the square and rectangle and even the parallelogram, the triangle, the trapezoid, the circle, or any other sort of shape, you do need to refer to a formula. Unless, you need to refer to a formula. And you have to put in the data into the correct variable of your formula, push enter, and then spit out the answer. But there is one shape in particular that's unique. Does anybody know what shape that is?
Circle.
Yes, the famous circle. Beautiful circle. Hand drawn by me. Amazing. So, we're about to get into the fun stuff, which is the circle. The circle, my friends, is very unique. Very, very unique. There's 3 things that you're going to need to learn and memorize about the circle. First thing is something called the radius. Second thing is called the diameter. And third thing called the circumference. Circumference. And you know what? Fourth thing, just because, pi. So the radius on your formula, if you look at your formula sheet of an area of a circle or perimeter of a, and then it says circumference of a circle, I'll explain that in a sec, but if you refer to the formula sheet, if you look at those formulas, if you notice, they have a couple R's, they have a couple of D's, they have a couple of pi's in them. Well, that's exactly what these are. The radius is your R, but can anybody explain what the radius actually is of a circle? If you had to define what the radius is. Well, let me show you. The radius, my friends, is half the length of the circle. If you sort of put a dot in the middle of the circle and you run a line from that middle point to the edge of the circle, and let's say it measures, I don't know, 3, that is its radius, 3. And the beauty of a circle is that that 3 is the same length all around. That's what makes it a circle, right? So that's what the radius is. The diameter, does anybody want to give it a guess of what it might be? It's the full length. So, I mean, I could just continue on, but it doesn't matter because it's all the same length all around. So that's the full length from one end to the other end of the circle. So if the radius of this circle is 3, what is the diameter? 6. If it helps you to remember it, think of it like this. The radius is half the length of diameter. Diameter is double the length of the radius. That's gonna come in handy soon. Circumference. Does anybody know what the circumference is?
Like a perimeter.
Exactly. The circumference, my friends, all it is the perimeter. It is the outside length. It is literally the outside measurement of the circle. So, why do they call it a circumference? It's because perimeter literally means, you know, the outside of the shape in terms of sides. Does the circle have a side? No, that's the beauty of this shape. It doesn't have any edge. It doesn't have no side. So they just decided to rename it circumference. But think of it identical to the perimeter. That's why it's on your formula sheet. It's under the perimeter of a blank section. There's a reason why it's there. It's because circumference, all it means is, think of it as the outside of the circle, the perimeter. That little symbol there is called pi, aka, for us, 3.14. That's an actual number. You're going to have to use that. .14. So now that we learned a little bit of stuff in terms of the circle, how about we find the area of this particular circle? So we're given both. We're given the radius of 3 and the diameter of 6. It doesn't matter. Either or, we could figure it out. You know what? Let's pretend they didn't give us the radius, and instead they just gave us the diameter of 6. They gave us the diameter of 6. Tell me, what is the area of the following circle? Well, ask your 3 things. What are they asking for? Well, they're asking for the area, duh. They just said it, right? What shape is in front of you?
Circle.
Well, they just said it in the question itself. What is the area of the circle? So you know a circle is what's in front of you. Step number 3, go hunt down for the formula of that specific shape and for that specific question. So let's go to the area of a circle formula. And can somebody shout out the area of a circle formula? A equals pi r squared. There it is. You just located it. Now what do? You fill in the variables with the correct data. So area equals pi. What's pi? 3.14 radius squared. What's my radius of the following circle?
Is it 3?
6. Is that 3?
3.
Right? It's 3. So that's the trip up. That's what they love doing on tests and on the GED and all that. They love giving you a circle with the diameter being shown, knowing that through, just rushing and everything, you're going to accidentally put 6 in here, when in reality that's wrong because the formula specifically says R, which stands for radius, which means, what is the radius of the following circle? It's half the diameter, which is 3. Sometimes they will give you a figure with the radius, and you just put that number in, right? But watch out for the little things, because that is what's going to get you. So just like before, now that you've followed your 4 steps and you filled in your formula, all you have to do is figure that out via the calculator. Tell me 3.14 times 3 squared. What is the final answer?
28.26.
I have a 28.26. Does anybody else? 0.26. Does anybody else have something different? Well, then that's your area. The area of this following circle is 28.26 whatever. Cubic inches, cubic feet, cubic whatever of water, of fertilizer, whatever the word problem is, they'll give you the units. So that's how you found the area. You use the formula, the area of a circle formula. So now, that same circle, can somebody please tell me the perimeter, or sorry, my apologies, the circumference of the following, that same circle? Well, shouldn't intimidate you in any way, shape, or form. All we need to do is really do the same thing, but now using the circumference of a circle formula. So tell me, what is the circumference of a circle formula? The perimeter of a circle formula. If you look at your formula sheets and you go to the perimeter of a circumference of a circle, we are actually given 2. We are given C equals 2 pi R, or C equals pi D. Honestly, it doesn't matter which one you use as long as you put the correct variable in. But yeah, they gave us the benefit of actually using 2 formulas, and it's all dependent on what they gave you. In this specific figure here, they gave us the diameter of 6. Am I correct? So chances are you're going to want to use the second formula, which has pi d. D stands for diameter. And all you need to do is C equals 3.14 times D, which is the 6. All you have to do is that, 3.14 times 6. And what do we get? What is it? 18.14? 84. 18.84. So what if you wanted to use this formula? Well, you can. You just got to watch out that you used R, right? So you'll actually do 2 times 3.14 times R, which is my 3. That will give you the same exact answer. So either you decide to use the first formula or the second formula, it doesn't matter. As long as you make sure to put in the correct, either the radius or the diameter. My friends, do we see the pattern of finding the area and perimeter of 2D shapes? The pattern is pretty simple. Find out what they're asking for. Determine what shape is in front of you. Go locate that shape's formula to answer the question. Fill in the correct data and the correct variables and then solve. It's just a continuous step like that. You have to always refer to the formula sheet, and formula sheet. Nothing else. Now, one very last thing. One very last thing. Is shapes that happen to look like this. Actually, let me do this. That is, without a doubt, the most beautifulest figure I've ever drawn in my life. That is incredible right there. So, now we're getting into the fun stuff. Fun geometry stuff. So, what two shapes do we see here? Actually, what's the big shape that we see? A circle. The only problem, my friends, is that that circle has a gaping hole in the middle of it, right? That gaping hole happens to have a shape of a rectangle. The question is this. The following figure below again is somebody's backyard in the shape of a circle. It has some sort of play house thing in the middle, and with its dimension being 2 feet by 3 feet, right? They just want to know how much grass is needed to be placed in the grass area. Obviously, it doesn't make sense to plant grass in here because that's where the playpen is or whatever, right? So the thing is, my friends, when it comes down to questions like these, you have to do a little something. You are going to have to find the area of, yes, the full figure, which is the circle. But then what you're also going to have to do is find the area of the following hole or house or whatever it is. And then, in this specific case, subtract them. Find the difference between the two, and that gives you the leftover of just the shaded portion, which is just the grassy portion that we are trying to look for. Does that make sense? So we are trying to find the area of both figures, then we're going to subtract them, and that gives us the remaining part. That just gives us the shaded portion. So how about we do that? Let's first find the area of the circle. Let's pretend that this hole was never here. Let's just find the whole area of the circle. Well, first things first, you have to locate the formula of the area of a circle formula, which, if we remember, was area equals pi r squared. So A equals 3.14. What's my radius of the circle? Can anybody tell me what's the radius of the circle? 4. Because they gave us this little height here, this little length, which is the same as the diameter from one side all the way down to the bottom. It's a length of 8. But that's the diameter. The formula needs the radius. So 4 is obviously half of 8, which is the radius. And then we square that. Can somebody please tell me what all that comes out to be?
50.24.
50.24. Anybody get something different? So 50.24 is the radius of that whole circle. Now, let's go into the other shape, the little playpen that has a dimension of 2 feet by 3 feet. What is the area of that figure there? Well, I mean, I guess you could take the long route and do the same, use the same techniques that we just did. determine what shape it is. That is a rectangle. Go look for the rectangle, the area of a rectangle formula, which happens to be A equals length times width. So A equals, what's my length? 2 is fine. Width is 3. 2 times 3 is what? 6. So the area of the little playpen inside happens to be 6. So now, what is the area of just the shaded portion, of just this little shaded portion that I'm shading in right now?
44.24.
The only thing you have to do last is to subtract 6 from 50.24. So 50.24 minus 6, and what do we get?
44.24.
So the area of just the shaded portion is 44.24. Watch out for questions like those ones. Watch out for them. But all it is really is finding the area again, but just 2 separate times for 2 separate shapes that you could identify, and then either subtracting or adding. There's sometimes, you might sometimes have to add at the end. When would you add at the end? Well, they're pretty easy to spot. Whenever you see, when you don't see a hole in the middle, when you see an actual add-on, actually, yeah, that one's fine. What you would have to do is actually split this, find the area of this rectangle, find the area of this half circle, add them up at the end, right? These are how these are the type of figures that you would have to add at the end. When they actually look like they're more. We're going to do a lot of these next week with combined figures, right? It's our job to split them. Where could you see the 2 shapes? Once you made that split, finding the area of those 2 shapes and then adding them at the end. So these are the ones that you add. Whenever you see a gaping hole in the middle or a shaded region that needs to be figured out, that's usually when you have to subtract. Here's an example of when you're supposed to add at the end. Let's say we're given a dimension of, let's say, 3. This one is 4. This one is 8. And this is, ooh, this is a good example. I should have done, yeah, this, I have to go over this anyways. So perfect. So this is an example of when you have to add at the end. So tell me, what 2 shapes do you see? I see either 2 rectangles or a rectangle and a square. We don't know until we see the measurements. But you want to make your split, right? Either you're a student that splits there or you're a student that splits there. It all depends whether you can find all the missing dimensions. For instance, this big rectangle right here. In order to find the area, all I have to do is multiply 2 sides. So I get this 8 and I multiply it with this unknown dimension there. My friends, the beauty about geometry is that you could always find the missing dimension just by looking. Can somebody please tell me what measurement this is right here? I have a 6. How did we get 6 though? Well, look at this. From here to there, it's 9, right? But the beauty is, from here to there, it's 3. So what is this remaining part here, the missing number? Well, it's just 9 minus 3. That gives you that little remainder, which is the 6. That same technique is going to be used to find the length of that missing side for this little miniature square or rectangle part. Tell me, what is the length of this side? 4. Why? Because from here to there it's 8. But from here to there it's 4. So, I mean, if here to there it's 4, here to there has to be 4 because that would give me the total length of 8. That's going to be key for later geometry. So, you just found all the lengths. Now, just find me the area of each one. What's the area of that big rectangle? Remember, area for the rectangle is length times width. So, length is 6, width is 8. I totally got that backwards, but it's fine. It doesn't matter. 8 times 6 is what?
48. Oh,
8 times 6? Huh?
48.
Don't say sorry. What about the area of this? Oh, sorry. Well, yeah. So that is the length. That's the area of this rectangle. What about this little section here? What is 3 times 4? So this is the time. In order to find the area of the whole figure that we originally were given, we had to do all of this so that we can then add that 48 plus 12. What's 48 plus 12? So the area of the original figure was 60 whatever. So that's when you have to add.